Good morning friends, I am Dr. Sachin Wani from Pillai College of Engineering. So today's topic is numerical methods. In numerical methods, today we learn regular Falsi method. But before we learn regular Falsi method, let me ask you some questions so that I will let you know how much you know about that. Suppose we want to find out the roots of the equation. How you are finding the roots of equation? Yes, to find the roots of equation, that is a quadratic equation I am talking. Suppose I will write one equation. Suppose this is my equation. My equation is suppose x square minus 3x plus 2 is equal to 0. How you will solve this equation? There are different ways to solve the equation. Either you can factorize, that is we can find out the factor directly, that is x minus 1 into x minus 2 is equal to 0. Therefore we got the value of x as 1 or x as 2. This is one method. Or the best way to solve this quadratic equation is x is equal to minus b plus or minus the root of b square minus 4ac, this total divided by 2a. If you don't know how to factorize, then we can use this as a formula, which is a standard one. This is okay if the quadratic equation is given and we know the method to find out the roots. But what you will do if we have cubic equation or equation of degree 4th or equation 5th? For cubic 4th we can manage, but what about 5th, 6th? It's very difficult to find the roots of this equation. As well as suppose we have this equation. Suppose I will write x log x minus 10 equal to 0, or you can say sin x plus cos x is equal to 0. How you will find the roots of this equation? There is no method available. So these equations actually called as transcendental equation. Transcendental equation. The equation which contains trigonometric function, logarithmic function, or sometimes exponential function are called as transcendental equation. To solve this transcendental equation, our analytical method will not work. So in that case, we have to think of alternative. And that alternative is a numerical method. So there are lots of numerical methods are available to find out the solution of these equations. So to find out these solutions, we have different methods. Correct. Now let me give an example. Numerical methods are iterative methods. That is, it will not give the exact solution. Sometimes it gives, but these are iterative methods. So iterative means to get the value of this x, that is this x, first you have to find out x1, x2, x3, x4 and so on. Means if for this function, right, if you have any function and we know that this is the root of this, right, now initially we'll get the value x1, then we'll get x2, then we'll get x3, and so the solution is closer and closer to this point. So after some finite number of steps we'll get the solution. Now so what is this regular Falsi method is? So in regular Falsi method, if we see, this is our regular Falsi method. That is one formula. After writing this formula, we get first iteration, second iteration and third iteration, so on. Now it is used to find the roots of transcendental or algebraic equations sometimes. It requires two initial points to start the iteration, and f of a into f of b should be negative, right? Since this is a regular Falsi method, we require two initial point, that is a and b, and the condition on that a and b is f of a into f of b, this should be negative, otherwise you will not get the root. Actually this is initial value theorem, that if the root lies between 2 points, then the product of the values of their function is negative, right? Then we get a formula to find out this. X1 is equal to a into f of b minus b into f of a divided by f of b minus f of a. So this is a formula of regular Falsi method. With the help of this we can find out the solution. So be careful, you have to memorize this. There is no other option. Now then we try to find out x2. To find out x2, again we write the same formula, int f of b minus b int f of f1 f of b minus f of a, but in that case a and b are different. Now if you continue this procedure till the last two approximations give the same value, means how many iterations will perform, that is the question. So the rule is, if we get last two approximations same, then stop. It means what? Suppose we got the value of x2, suppose, okay, x2 is suppose 0.5378, right? Then suppose x3 is equal to, we have 0.5371. Both are not same because this 8, this is 1. So again we have to find out x4. And now if x4 is 0.5370, still these are not same. But in x5, suppose we are getting 0.5370. Now these both are same. So we can stop and we can say that this x5 is equal to 0.5370 is the root of given equation. Is it clear? Now, so let us solve first example with the help of this concept. So only one formula is important, this, and it's very important to choose A and B after each iteration. The new values of A and B depending on this condition. So let us write down the first example. First example is, use regular Falsi method to solve the following equation. Now what will happen in some of the examples, the initial value a and b is given. So if they are given, then no problem, we can directly write a, b, and we can start finding the value of x1. But in some of the problems, these a and b are not given. Then what you will do? If a and b are not given, then you have to find out it by some precision. So here, suppose we write first example, f of x is equal to x cube minus 2x minus 5 is equal to 0, and value of a is 2, value of b is equal to 2.5. Okay, now here the value of a and b is given, but suppose these are not given, then how you will find? In that case, we have to first find out f of 0, f of 1 means here, I will write something here. Here, if these are not given, uh, f of 0, then find out f of 1, then find out f of 2, then find out f of 3, and so on. What is f of 0? Minus 5. Find f of 1. 1 minus 7, so it's minus 6, right? Then if you put 2, 8 minus 4, 4 minus 5 is again negative, minus 1. But if you put 3, it's 27 minus 21 minus 5, 16. So this is negative, this is positive, so the root lies between the 2 points 2 and 3. So we can take the average of this 2 and 3, that is 2 plus 3 divided by 2, that is 2.5. So you can write a is equal to 2 because this is negative, and f of 2.5, this is positive 100%, therefore b is equal to 2.5. So in this problem a is 2 and b is 2.5 is already given, so don't bother about it. But this is the method to find out this a and b. The same I have explained here. Here f of 0 is 0 cube minus, that is minus 5, f of 1 is minus 6, then f of 2 is equivalent to minus 1, and f of 3 is equal to 16. Therefore f of 2.5, which is positive, therefore we can choose the average of these two as a and b. And now we know the regular Falsi method. x1 is equal to a into f of b minus b into f of a divided by f of b minus f of a. Now these are given for our reference. Function, value of f of 2.5, value of f of 2. Now put all these values here. So what do we get? So we get first iteration, that is x1 is equal to. Now put the value of a and b here. A is 2, b is 2.5. So x1 is 2 into f of 2.5 minus 2.5 into f of 2 divided by f of 2.5 minus f of 2. Therefore, x1 is equal to 2 into f of 2.5 is 5.625. We know the value, this put here, minus 2.5 into f of 2 is minus 1 divided by 5.625, which is the value of f of 2.5 minus f of 2 is minus 1. Now with the help of calculator we will get directly the answer. So x1 is equal to, calculate the value, after calculation we will get 2.0755. So this is x1. Now after getting x1, the next step is important because you have to choose new a and b. So let us find out first what is f of 2.0755, which is again a negative number. Now f of 2.5 is a positive, f of 2.075 is a negative, so the root lies between, right? Again formula is same, that x2. In second iteration, a is 2.0755, b is 2.5, therefore 2.0755 into f of b, that is 2.5 minus b 2.5 into f of 2.5 divided by f of 2.0755 minus f of a, that is 2.0755. Again, substitute the value of each term. We already know the value of f of 2.0755, that is this. F of 2 is minus 1. Substitute all the values here. So what we obtain? Put the value of each term. This one. Now with the help of calculator, if you calculate, we get x2 is equal to 2.090. Then immediately find out the value of f of 2.098, this one. And the value is negative. This is also negative. This is positive. So where the root lies between? Root lies between 2.0908 and 2.5. So our A is this and B is this. So it's changing. So again the same regular Falsi method formula in the third iteration. A is this, B is this. So x3 is equal to, substitute the value, A into f of B minus B into f of A upon f of B minus f of A. We are just putting the values in the same formula. Only the skills are where how you choose A and B, that is more important. And remaining is just mechanical. Just substitute the value, use calculator, and you will get the answer x3. Similarly, x4 also you can do the same thing again. Find new A and B, substitute the value, and we'll get x4 2.094. Then next is fifth iteration also same, and then sixth iteration. We are continuously finding this because if you observe, the values are not coming same. If you observe x4, this one. Now this is our x5. x5 is 2.0945. This is 2.0945. So both are same. Therefore, we can stop here. We can stop and we can say that 2.0945 is the root of given equation. So we can write, therefore, the root of the given equation is 2.0945. So in this lecture, we have learned how to use Regula Falsi method to solve transcendental equation. And the main point is that you have to find out the solution by this iterative method. This is iterative method. So after some finite number of iterations, you will get the solution. Here we got 6 iterations. We solved the problem up to 6 iterations to get the answer. And the rule is that you have to find out the solution up till the last 2 approximations give the same value. So in the next lecture, we will solve one more problem of the Regula Falsi method. Thank you.